Between yesterday and notes and today's problem of the day, we did the work for the derivative of tangent and cotangent. I won't make us go through the quotient rule for secant and cosecant, but you could rewrite those as 1 over sine, 1 over cosine, do the quotient rule. But when you do that, these are your derivatives, okay? Please write these down, circle them, highlight them, star them. You need to know these, and it is my expectation that you know these derivatives. Are you seeing a little bit of, I don't know if I want to say a relationship or a pattern, but there's a little bit of similarities between the derivatives of tangent and cotangent, as well as the derivatives of secant and cosecant. Do you see that? Okay. So if you can remember that tangent is secant squared, all right, cotangent needs to be negative, and the other one, cosecant. Okay. If you can remember that secant's derivative is secant tangent, all right, then when we think about cosecant's derivative, it needs to be negative, and with the other ones, cosecant, cotangent. Okay. These two plus the sine and cosine rules, those 6, there's nothing else I can do but tell you, you need to know them. You need to have them memorized. You will use them enough to where eventually they just become second nature to you, or that is my hope. Okay? But you need to know. Okay? So we'll do a little bit of practice using them here. We'll do 3 examples. Okay? So go ahead and write down our first one. G of x is x minus tangent of x. And you know what? Before we talk about it together, try it yourself. Write down what you think the derivative is. You know why you're all tired today? You haven't had a 5-day week in like 3 weeks. I'm not used to it. Okay, just so you feel less intimidated, turn to your neighbor, tell them what you got for the derivative, see what they got. All right, Lauren, what is your derivative?
1 minus secant squared x.
1 minus secant squared x. Chris, is she right? That's what you got. 1 minus secant squared x. The derivative of x is 1. The derivative of tangent is secant squared. There you go. It's as simple as that. What improved? Okay, write this one down. I won't do that to you. Okay. I know I hear some like, oh, it's gonna get harder. Here's the deal, people. If you are not a little bit uncomfortable, then that means you're not learning. So it takes a little bit of feeling uneasy in order to learn something. Okay, that's just how it goes. All right. Eli, what are we working with here? You don't have to tell me your derivative. Just what are we working with? Just secant? Okay, and we put those together and they make a...
It's a product.
Oh, it's a product. And if we have a product of two functions, we have to use the product rule. Okay, so y prime, derivative of x times the secant of x plus x times the derivative of secant. Mindy, what's the derivative of secant? What would we write down? There we go.
Yeah, right. Yeah. That's what I got.
Whether it looks better or not, it's right. And that's what's more important, right, Sean? That it's correct. All right, one more trig. One more trig. Write this down. One minus cosine squared. But that's not 1 minus cosine squared. That's 1 minus cosine. Okay. There are a couple different ways we could go about this problem. So before you start calculating away, I would like you to have a discussion with your pod how you would feel the most comfortable taking the derivative of this problem. Just go ahead and talk about what you would do.
I would y over sine of x.
I do like 1 over sine of x minus.
All right. Pod 1, did you, what way, Colby, I'll let you speak on their behalf. What?
Quotient.
You talked about the quotient rule. Okay. Pod 5, did you talk about the quotient rule?
Yeah.
Okay. Pod 4, did you talk about the quotient rule?
You said split it up to do 1 over sine of x minus cosine of x over sine of x.
Okay, did you hear that? 1 over sine of x minus cosine of x over sine of x. Okay, so let's go ahead and let's just take the quotient rule just for practice. Okay, quotient rule. The derivative of our numerator, Aaron, what would the derivative of our numerator be? Like if we're going to take the quotient rule, we want the derivative of our numerator times the denominator. What would the derivative of 1 minus cosine x be equal to? Would it just be sine of x? Would it just be sine of x, Turner?
Yes.
Yes. Okay. Emma, why is it just sine of x?
Because 1 goes to 0,
Mhm.
and then negative cosine x, like cosine x switches to negative sine x, but you already have negative sine x.
Okay, good. Minus numerator times the derivative of our denominator all over the denominator squared. make that look prettier, right? We don't have to, but we could. And if we did, we would have sine squared minus cosine plus cosine squared x, right? And then we could say, cool, sine squared plus cosine is 1, and we'd have 1 minus cosine of x over sine squared x, and we could just keep going, and there's really no need for that, okay? This would be sufficient. Now, Nick, were you the one telling me about Nick's suggestion, or Pod 4's suggestion, whether it was Nick's or not, I don't know. We could write this as 1 over sine of x minus cosine of x over sine of x. Okay. What is 1 over sine of x? Minus cosine over sine. Okay. So now when we're taking the derivative, no quotient rule. We just have 2 simple rules. Okay. So Sean, cosecant's derivative is what?
Negative cosecant x.
Excellent. Minus cotangent's derivative. Cotangent of x has a derivative of what, Nicole? Okay, so negative cosecant squared x. Okay. These two are the same. We could do lots of trig identities to get this down to this right here, but it's not necessary. Okay. However, now that we've done both ways, how many of you liked taking the quotient rule better? How many of you liked just doing the trig derivatives better? Okay, and we all have our preferences, and that's totally fine. Okay?
I mean, in this case, it's
But it could be, you're right, in this case it was easier, maybe it's not going to be all the time. Okay? Alright, so let's talk about some notation. First derivative, these are the 4 different notations we see. Y prime, or we see f prime of x, or we see dy dx, or d dx of our function. This is where things get exciting. But now, if you wanted to find the derivative again, Nicole, we could find the second derivative. And what we would do is we would put 2 primes. Y double prime. F double prime. And then you would get these squares, d squared y over dx squared, to represent the second derivative. Right now, we're just worried about finding them. In Unit 3, I'll tell you what the second derivative can help us with. But the second derivative is just the rate of change of the rate of change. My screen shade is still covering more, isn't it? The third derivative, we have 3 tick marks. Well, okay. So you're like, oh, I'm seeing a pattern. But what if I ask you for like the 10th derivative? Are you going to go 1, 2, 3, 4, 5, 6, 7? Once we get to the 4th derivative, we can notate using numbers. And that's why here is your like nth derivative stuff, okay?
I kind of do it. Just like
Yes, we get, like, we're gonna talk about differentials here.
No, there's probably
I guess
some
next
formula.
chapter.
Is there a formula?
What?
Is there a formula?
Just do that actually.
Do it. So you're just more asking why is it with the D and the EX? I don't know if I have a very good answer for you right this second. Okay? Let me think about it. Yeah, so this is just like the nth derivative. But once you get to the fourth derivative, those tick marks can become numbers. But notice how they're in parentheses. So it's not like y to the fourth, it's y, fourth derivative. Okay, do you see the difference? Okay, so Colby just asked me, was there like a formula? Or if I have to find the 10th derivative, do I have to take the 10 derivatives? Technically, you have to take each derivative. However, there are some functions where you could see patterns in, right? What's the derivative of sine? What's the derivative of cosine? Negative sine. What's the derivative of negative sine? Negative cosine. What's the derivative of negative cosine? Sine. Okay? That is a derivative where you would see patterns. Okay? It would like rotate through a pattern. Also, let's think about a polynomial. Please write down this polynomial. Some of you know what this derivative is without taking it. You don't have to know it.
Oh.
I'm just saying some of you may know. That is no. That word's not allowed. Not in my classroom.
I'll just walk out.
Okay, so let's talk about the first derivative. Let's talk about the first derivative. Kira, I want you to help me with the first derivative.
3x squared minus 10x plus 6.
Excellent. Our second derivative is we take 3x squared minus 10x plus 6, and we take that derivative. Okay? Caleb, can you help me out with that one?
That would be 6x minus 10.
Did you say 6x?
Yes.
Okay. Okay. Our third derivative. Our third derivative means we take 6x minus 10 and take the derivative. Everybody all together, what is that?
6.
Okay. Our fourth derivative. Lauren, what's the derivative of 6? And what's the derivative of 0? Our fifth derivative is 0. Well, the degree of the polynomial with the number of terms and the derivative that I'm asking of you can all factor into maybe we don't have to write all of our work down, okay? If I'm asking you for the fifth derivative of a cubic function, okay, we've run out of degrees by the time we get to our fifth derivative, which is why I said some of you may have been thinking ahead knowing we were going to run out of the power rule, okay? Now, if I would have asked you for the third derivative, okay, you might have thought, okay, these terms right here don't matter, right? If I had like 2x to the 32nd and I asked you for the 10th derivative, we can think about the power rule over and over and over, and without having to do all 10 derivatives, we might be able to figure out what that would be. You see what I'm saying? Okay, our polynomial is just going to have that power rule happen over and over. So our coefficients, or our degrees, keep going out to the coefficient. Okay, so Colby was kind of like a weird answer. Like, yes, we have to take the 10 derivatives, but we can look for patterns if they're there. Okay? Like, do you want to talk about something simple like x to the 12th power? Our first derivative, 12x to the 11. Our second derivative, 11 times 12, x to the 10th. Our third derivative, 12 times 11 times 10, x to the 9th. Do you see where this is going?
Right. So when we have to multiply out 12 times 11 times 10, or we just put that there like on the x.
Well, if we got all the way down to like the 12th derivative, you could just say 12 factorial.
So like on a test, we could just leave it as 12 times 11 times 10 times x to the 9th power. Or do we need to multiply it out to be?
Well, if you have your calculator, yeah, you're going to multiply it out. Without a calculator, I wouldn't get too upset about it. Okay. Last example. Okay, so we've had some really good conversations. I'm sorry that I'm not going to get you to working on your homework before you leave, but we've been talking about some really nice things. So thank you for participating. I'm going to give you a moment to write down this table. Okay, this is a very common AP style question for like a multiple choice question. What I am going to ask you, and you don't need to write down these words, but this is what it would say with it. It would say the table above gives values for two differentiable functions and their derivatives at selected values of x. Okay? It's important that we understand that both functions are differentiable so that these values actually exist. Okay? What we're going to find is this. This is what I want you to write down. H prime of 0 if h of x is f of x divided by g of x. Okay. All right. They've presented us with a quotient. Okay. It doesn't matter that we don't know what f of x is. It doesn't matter that we don't know what g of x is. We know that we have a quotient. So we can do the quotient rule. So the derivative of h is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. That is the quotient rule. Always, always, always find your derivative in terms of x first, then worry about plugging in a value. Okay? Now that we have our derivative in terms of x, they're asking us for h prime of 0. Okay? So if we plug 0 in, we want f prime of 0 times g of 0 minus f of 0 times g prime of 0 all over g of 0 squared. At this point, what do we have to do? Look at the chart. Okay, now it's just a matter of which values go where. So help me out. F prime of 0. What is it? -3. G of 0. 5. Minus f of 0. G prime of 0. And then you already told me that g of 0 was 5. So what we have is -13 over 25. Sorry. There's really not a good place to sit in this room. All right, so your homework Your homework for this evening, it looks like you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 problems. Plus, you have like 15 problems, but they're not all like take this derivative problems. Okay? I think 103 to 108 might be like true or false or matching or something like that. Okay?